Hello guys, and welcome to this new Java Lab tutorial. In this video we will cover the topic of distributed tracing. So in the past, when we used to deal with big application in terms of big monoliths which runs in a single process, then we use kind of logs inside our application to track the failure which may occur. But and that was feasible and helpful in this context. But as you in the world of distributed systems, when you will end up with having a couple of microservices, let's say 100 of microservices, then it gets harder to track the failures across all the services. And this is where the distributed tracing is coming into picture. Before starting with the code part, the demo part, we should understand some kind of terms used in this context. So when we talk in terms of distributed system, then we have the term of trace. Trace is the description, so it describes transactions as it moves through a distributed system. That means it describes the transaction across all the affected microservices. Then we have the term of span. Span is a named and timed operation that means it has a name and it has a start and end time and a duration. And the span describes a piece of work which is needed to accomplish the whole transaction. Then we have the span context. This is an article from OpenTracing.io, which I think is very useful and very compact. Will describe also with the information which you need in order to understand this distributed tracing concept. Then we have the span context. Span context contains the trace identifier, which will be the same across all the spans, and then it includes also a span identifier and any other data that the tracing system needs to propagate to the downstream service. Yeah, spans can have relationships between each other. Let me show you where it is. For example, as you can see here, we have the parent span, and the first one, the parent span, will be the parent of the flow span, and so on. And this one can be, in his term, also a parent of the following spans, and so on. That means, like this, the trace can correlate and puts this span into relation in order to visualize this in using a visualization system, which we will use in a couple of minutes. Yeah, I have here a simple application made up of several microservices. I have a client microservice. But before that, let me mention something. With the Spring Cloud Sleuth, your application, Spring Boot application, will be, if you put this dependency in the class path, then your microservices in terms of Spring Boot application will be able to generate traces, which you can see in the log. And on top of that, if you put the second dependency, Spring Cloud Sleuth Zipkin, then this trace data, which will be generated by Sleuth, will be forwarded to the Zipkin server, and all that we will see in a couple of minutes. That means here I have a couple of microservices, a client microservice, and all this is very necessary. All the microservices which you want to show and visualize in the Zipkin, in the visualization server or visualization system, they have to have this dependency. We will use Zipkin. That means we need this dependency in order to send the trace data, which will be generated by Sleuth, to the Zipkin server. I have, as I told, a client microservice. which will call in turns will call a second service 1 microservice, and service 1 in terms calls service 2, and service 2 in his term calls service 3, and so on. That means we will have this picture here. I have a client which call service 1 calls service 2, and so on till the server which will deliver us a simple string. This is nothing fancy in this application. Yeah, I have started already, and as I told, all these microservices have these both dependencies. This is very necessary. And on top of that, you have you have to define a name of your application, and you should also tell your Spring Boot application or microservices where the Zipkin server is running. It's running in this case, in our case, or in my case, on localhost port 9411. And this information I put in all microservices, like here, name of the application service 1, and here again I mentioned where the server Zipkin server is running, which we'll use to visualize the trace data. Yeah, and again here both dependencies are mandatory in order to generate. Sleuth will generate the trace data, and this dependency is acting as a kind of client to the Zipkin server in order to visualize the data. Yeah, let me restart this service. All other services, I guess, I have started already. Service 1 is starting. Let me clear here this stuff here. Service 2 is running. Service 3 also running. And 4 and the Microsoft which I called server. As I told, the client will send a request and to the service 1, and service 1 in his turn will call service 2, and so on. And at the end, we will get this message. This is a fancy Sleuth application. And they have already started the Zipkin server, yeah, using the jar. Let me restart it again. So this is a jar which you can download and use to start the Zipkin server. So Zipkin server is getting started, and here you can find the traces. Yeah. Right now nothing is there because I have to send the request first. Yeah. And now if here, let's refresh again. So here we have all our microservices, client, server, service 1, and so on, service 4. And here we got a trace, which we can double click in order to analyze our request flow. The client send the request, get client message, which will call the service 1, and service 1 will call service 2, and so on. Yeah. This is the span. This is one of the span. Yeah. Yeah, it has a start date and end date, and it has key value description of the method name, which method name has been called, what was the controller which is responsible for the call, and here you have a trace ID. This is the trace ID which will be the same across all the spans, and here we have a span, and since this is the first span, there are no parent ID because there are no incoming requests to the client. The client was the first one who triggered the request. That's why there is no parent ID, no parent span. Let's have a look to the service 1, for example, span. Here again, this is the method, the path of the method, the controller which is responsible for the get mapping request. I have the controller here, my controller. This is the service 1 controller which provide a get mapping message. The same pattern I used overall across all the services. Like here again, service 2, the same pattern again, message as endpoint and the service 2 will call service 3. Here, the trace ID is the same as the first one. You can here remark, remember 786E. If we analyze the one here, 786E, this is trace ID, and this is the span ID, and this span ID will be now the parent of the next span. Yeah, let's fetch it. As you can see here, the parent, the first span ID, which was also the same as the trace ID for the client, because the client is the first one who triggered the request. That's why here the trace ID is the same across all the spans, and the first span ID is the parent of the next span, and so on. Here again, the trace ID is the same, yeah, and now this ID is the ID of this one. If I haven't done any failure, yeah, that means this span is now the parent of the next span, and so on. Everything is good. Now let's cause some failure. Yeah, let's, for example, shut down the service 3. Yeah, let's shut down the service 3 and see what will happen. Okay, now we shut down the service 3. If we try to get a message, then we end up in a failure, and here we can go here again, find traces. We can select the newest one, and here this is the trace where the request failed. The last one here, since we shut down the service 3, then the request gets stuck in service 2. Yeah, and we see here, if we double click, if we click on the span, then we can see here error connection refused. We are trying to hit this endpoint service 3 message, but since we shut down the service 3, then the connection was refused. In the previous span, you can see here, description of the error. Yeah, that means the span, as we saw in the concept, in this article here, that's the span context contains also logs. Yeah, in this case, an error log, which tell us that this endpoint has refused the connection since we shut down the service 3. And this is where this distributed tracing is coming into picture and make us the life very easier and simple to analyze the errors. Now let's restart the service 3 again and see what will happen. Now we should be able to see our message. This is a fancy, with this message, this is a fancy application. Let's try it again. Yeah, and here you are. We have now our application, service 3 is running and no problem. Now let's find the traces again. And this is the newest one. You can also filter here and find traces, this newest one, and we are now safe. So, and here also you can also have a look to your dependencies between the services. Now this is our services. Yeah, it's here very simple, but you can end up in a big application with more than this services, where a lot of a lot of microservices talk to each other. Then we'll end up with a very complicated graph as this one, which is shown here. Yeah, let's recap, summarize what we have done. We use the Spring Cloud Sleuth in order to generate trace data. And in addition to this, you can see here, this is the name of the service, this is the trace ID, and this is the span ID. That means the trace data, the Sleuth will generate the trace data in the log also. But if we use also this dependency Spring Cloud Sleuth, then we will be able to visualize, to send this trace data to Zipkin as our visualization tool, and visualize the data as we saw before. And again, both dependencies are mandatory for all the services which you want, for which you want to visualize the trace data. I hope this video was helpful for you, and yeah, I'm looking forward to see you in further videos. Bye.